Okay, example 6 on 7.2. A car traveled 3.0 miles at a heading of 78 degrees. The road turned. The car traveled another 4.3 miles at a heading of 138 degrees. Find the distance and bearing of the car from the starting point. So, if we're doing heading, we want to draw a north-south line and a starting point, let's just say right here. Somewhere along that north-south starting line. And a heading of 78 degrees means that the car is going 78 degrees clockwise, starting at 0 up here. So straight up is 0, so 78 degrees means he's going this way for 3 miles. And the 78 degree angle is measured from north to the vector of the car, like so. And he traveled 3.0 miles on that heading. It's 3.0. Dang it. 78 degrees. My eraser's too big. There, 3.0 miles. All right. From that point, he's going to travel at a heading of 138 degrees. So we're at a new position, so we want to draw another north-south line at our position. Our position is where we are, which is right here. And now he's traveling at a heading of 138 degrees. So again, if I'm measuring 0 straight up, there's 90. 138 is going to be over kind of like this. And this is 4.3 miles, so I do it a little bit longer. But 138 degrees is measured here, and 4.3 miles. So the question asks us to find the distance and bearing of the car from the starting point. So the question specifically here is 2 parts. Part 1, how long is this? Part 2, what is the angle right here? Alright? Now what I want you to see out of this, I'm going to erase that angle, that black angle there, and the black angle is simply 78 plus this little extra piece here, right? So if I can figure out this angle in here, let's call this theta. 78 degrees plus theta is the angle we're looking for. And again, however long that black line is going to be the length of it. So what we're going to look at and ask ourselves is, what information do we have here? What type of information do we know? First off, if that's 78 degrees in there, this has to be 78 degrees right here. And if this is 138, this would have to be 42. So altogether, we have the ability to get that angle in the middle of those two sides, which would be 120 degrees altogether. So 120 degrees is the measure of the whole angle there. I use 2 different properties to get these angles. We have parallel lines cut by transversal, so the acute angles are equal in measure. Straight lines 180 degrees, so these angles are supplementary. So I use tools of geometry basically in order to figure out missing angles like that. Looking at the whole thing, this is a side, this is an angle, this is a side, and that's the order that they're in, side, angle, side. So the law of cosines is usable to find the missing piece. So if I'm trying to find x down here, using the law of cosines, I know that x squared is equal to 3 squared plus 4.3 squared minus 2 times 3 times 4.3 times cosine of 120. Get my calculator out and I just punch that in exactly what I'm seeing. I do make sure I'm in degrees before I start typing. If I'm going to use trigonometry, I always make sure I'm in the right mode. So 3 squared plus 4.3 squared minus 2 times 3 times 4.3 times cosine 120 comes out to 40.39. Which means x is simply going to equal the square root of that number. So the square root of 40.39 comes out to 6.36 miles. Okay, so that's part of the request. Find the distance. Oh, and it says in the bearing, not the. I thought it said heading instead of bearing. So maybe if it asks for heading, it's asking for this angle here, right? It's asking for bearing. Looking at this, just, I didn't draw it to scale, but it sure looks like it's going south of its original position, right? It might be safer to draw that to scale. Here's what I'm going to do. I'm going to use the law of sines to find this angle here. So I'm still going to find theta. All right. We can make a decision then whether or not this is going south or north at that point by how big theta is. Because again, I didn't draw it to scale to get a protractor and a ruler out when I drew it. So it looks like it's going south. Maybe it's not. So we'll see. So looking at the thing, we know this is 6.36 now. So the law of sines, 6.36 over the sine of 120 equals 4.3 over theta, sine of theta. So 6.36 over sine of 120 is equal to 4.3 over sine of theta. Okay. Obviously theta is going to be an acute angle because 120 degrees is an obtuse angle. So even though it's a side-side angle situation here that I'm using to get the missing piece, theta is going to be acute, so we only have to take an acute measure. Sine of 120 for punching a calculator is 0.8660. I've seen that one enough, I just happen to know what it is. And if I cross multiply, it's going to be this times this, goes multiplied divided by that. So 4.3 times 0.8660 divided by 6.36 comes out to 0.5885. So by inverse sine, 0.5885, that comes out to 36.05 degrees. Alright, so if I'm just going to go ahead and throw that in there, so it's 36.05 degrees. And this angle, this angle, this angle all together make a straight line. So if I do 180 minus these two angles, so 180 minus 78 minus 36.05, that comes out to 65.95. So I have the ability to get all those angles up in this corner, so 65.95 degrees. So again, I misread the problem to begin with, and I was thinking heading instead of bearing. So if it was a heading issue, I would just add these up to get the heading right. 114.05 degrees. It's asking for bearing though. Bearing is, first of all, the direction south and then the angle east or west. So we're looking south and we're going 65.95 degrees east. So the bearing is going to be south 65.95 degrees east. And again, had it asked for heading, it would have been 114.05 degrees. We didn't ask for that, but maybe they will another time. What heading should a person travel on in order to catch up with that person? Bearing makes more sense there because if the road turned, this is a road, that's a road, this isn't a road. You have to be in some off-road vehicle to get to them. So anyway, whole idea, just like the 7.1 problems, is draw the picture correctly based on heading and bearing. Heading is typically a line of motion, where bearing is usually a line of sight. But again, just know how to draw those 0 degrees straight up, and then go clockwise for heading. Look south or look north, then some degrees east or west.